So I'm running into a bit of a problem. I'm actually running low on space on this section here for the index laws, but fortunately for us, these next few concepts are not actually new index laws. They're actually extensions. The index laws extended on these two laws over here, are multiplication and division. So the idea is, if I have this situation here, for example, I've got two variables inside a bracket. So if I have, if we were to generalize that, ab to the power m, the question is, what do we do with that? We've actually had a bit of a hint of that when we looked at to the power 0, because remember how I said that if it's got brackets and it's both raised to the power 0, it applies to both of those variables individually, in a sense, right? So the same thing actually happens here. Because in this case they're different bases, what we tend to do is you write it like so. It's a to the power m, b to the power m, right? So the index would apply to both of them. Same thing if it's like a fractional kind of thing. So I've got a over b raised to the power, let's say m again, right? This m power is going to apply to both of these bases. So I'm still going to get a to the power m, b to the power m, right? So they're not really new index laws in a sense, or maybe they are, but essentially it's just looking at applying our existing index laws to these various situations. So what I mean by that is here, classic example, I've got this case 3 cubed and then c cubed. Remember, these are still multiplied together, right? So 3 cubed is 27, c cubed is just, that's what it is here. And then we can keep going. I've got here my expressions on the inside. I've got -4. Remember what I said about negatives? Because if you raise them to an even power, those negatives will actually cancel out. You end up with a positive number. But I'm still going to write it out in its entirety. So remember, this applies to each of these individually. So -4 is the thing I'm separating, and then I'm looking at these different bases, right? So I've got -4 all squared multiplied by, so I've got a to the power 4 all squared, and then b all squared, right? So let's look at these individually. -4 all squared, I know that's the same as -4 times -4, or 16. A to the power 4 all squared, well, we've got an index law to deal with that now. We don't have to think about writing that in the expanded notation. That's just a to the power 4 times 2, which is a to the power 8. And this last one here is just b squared, because I'm not doing anything else with that, right? So, not too bad. What about these next few ones? You want to try them yourself before I give them a go? Pause the video if you haven't already and see if you can have a go at these. But the whole idea is that I'm doing the same thing. I'm looking at, okay, this one's on the outside, so I'm going to leave that guy out for now. But same idea, right? So I'm raising each of these to the power 4 individually. So I've got x squared to the power 4. I've got y cubed to the power 4. And so you remember with your index laws that, again, it's the same thing. I'm doing a power to a power. So I'm going to multiply these out. That's going to be 2 times x to the power 2 times 4, which is 8. And this would be y to the power 3 times 4, which is 12. If you're not too sure about what's going on there, look back on the previous lesson on power to a power. That sort of explains what's going on here. Yeah. Same thing with these. Remember, we've got this sort of secondary index law, index rule. That's not really secondary. And I'm going to apply this cube to both of those. So I've got 5 cubed on a cubed. And 5 cubed, you can check in your calculator, but that's 125 on a cubed, right? So that's how you would simplify something like this. They can make them harder as well. Like you can get something like this. And remember, same idea. I've got this separate component, -a to the power 6, all over. Yeah, this one's a bit trickier because what's going to happen is I'm going to have to apply this twice, essentially. You could do it all in one go, but I'll just break it down for you, right? Because with this index law, it's saying that you apply the m to the numerator and the denominator, right? So numerator, denominator. But then here, you've got the same thing kind of what was happening with this previous one. So you've got lots of different terms going on in there. And so what's going to happen is, I'll do these separately. -a to the power 6, right? Well, that's just going to be a to the power 6 if you wanted to write that out in the expanded notation to check. This one, I'm going to get 3 to the power 6 x, and I'll skip some steps down because this is just going to be x to the power 2 times 6, or 12. That's just going to be y to the power 6. 3 to the power 6, we can probably evaluate. I can't evaluate in my head, unfortunately. So let's double check that. 3 to the power 6 is 729. Yeah, definitely wouldn't be able to get that. 729. Okay, cool. All right, so that's how we can think about some tricky examples. Last one here, bit of a challenge question. Pause the video again. Have a go. See what you can make of this one. Basically, the issue is that it's just a bit longer. There's a few more expressions involved, but at the end of the day, we're still using the same strategy, right? So let's break it down. So I've got a cubed, and so I guess what's the best way to do this? Let's break it up. We've got ab squared all cubed over m cubed. So I'm doing the numerators separately. Then I'm multiplying mb to the power 5 on a cubed to the power 5, right? And let's simplify this out. So on the numerator, I'm going to get a cubed b, I'm going to multiply these, so b to the power 6 over m cubed, multiplied by m to the power 5, b to the power 5, all over a to the power 15. I'm running out of room, so let's go over here. What's going to happen now is, you can do this in a few ways. I'm just going to bring them together, because remember, when you multiply fractions, you can just multiply the numerator, multiply the denominator, right? So I'm going to get a cubed b to the power 6, m to the power 5, and actually, sorry, there's a b to the power 5 here, so actually I can just add these, right? Because these are being multiplied across. So 6 plus 5 is 11, all divided by m cubed on a to the power 15. Okay, few things happening. So basically we've got lots of variables, and what's going to end up happening is we can still simplify, right? Because remember, anything with the same base, you can generally interact. So a cubed divided by a to the power 15, I'm going to be subtracting those. So 3 minus 15 is negative 12. b to the power 11 I can leave there. 5, take away 3, because I'm dividing. That's going to be m squared. And that's it. That's actually my answer. Notice when you do these just kind of divide through to 1. Or in your textbooks, we haven't done negative indices quite yet, but again, I've been hinting at what happens. What would happen is I could write this like so. But don't worry too much about that for now, because your textbooks may do that. I'm not too sure at this point, but we'll look into negative index law later. Anyway, that was a bit of a challenge question if you wanted to have a go at it. But the main ones, hopefully these ones all were quite clear in how they work and how all these different index laws interact with each other.